All right. And see, about 50% of you are somewhat familiar with it, and then we've got 25% are slightly and 25% are very. So it's a pretty diverse group, but you're all at least slightly familiar with it, which is great. And if you're ready, Mark, I'm going to go ahead and make you presenter.
Thanks,
Mark?
Rachel.
Okay, great.
Yep, I'm taking a look here. All right.
All right. There you go.
Very good. Thank you so much.
Thank you.
So good morning, and thank you all for attending today. I'm really looking forward to sharing information with you about our current appliance offerings that are jointly engineered from Microsoft and hardware vendors that we're working with on these. I'm going to get started today talking a little bit about our appliances overview and where we're going with our integrated hardware software solutions. Then focus us on the database consolidation and private cloud appliance, and talk with you about the product architecture. Go into some of the details on how we identify candidates for virtualization and consolidation and how we did container sizing on the appliance. It's a relevant aspect of the appliance for determining which workloads are most appropriate. And then we'll wrap up with some questions and answers at the end. When Microsoft initiated the development of our solutions around appliances, we built out capabilities around specific workloads that our customers told us were relevant to them and important for us to assist in bringing together in a more complete way. And so we began work with our parallel data warehouse, which is a large-scale data warehouse solution targeted at solving customer data warehouse problems in the 30 terabyte range and up. Although some customers are leveraging the performance capabilities of the appliance for smaller workloads, it's really capable of handling information in extraordinarily large sizes. And this solution, we believed, represented a challenge that was going to be, we were going to serve our customers by building this together in a more integrated way, leveraging hardware and software in a tuned and balanced appliance solution. So part of that decision resulted in our acquisition of Datalegro several years ago, and subsequently we have re-released that software and kind of merged it into our mainstream and have created appliances with, as you see here, Dell and Hewlett-Packard around parallel data warehouse appliance solutions. We also looked at some other workloads that our customers were telling us were relevant. The business data warehouse appliance is actually targeted at very small data warehouses. I'll say very small in the 1 to 5 terabyte range. And this is an area where customers, especially smaller mid-market customers and large customers looking for data marts, were saying, if you could just give us something that was tuned, balanced, and ready to go, we could actually get it up and running more quickly and take advantage of the performance optimizations that you could bake in through engineering efforts between Microsoft and hardware vendors. So we implemented and developed that business data warehouse appliance, and then followed it with the business decision appliance. The business decision appliance is actually a BI appliance that's designed to integrate and deliver Power Pivot experiences for both workbook designers and also corporate consumers within the organization. This is a tool that enables end users to access very powerful business intelligence objects through interactions online, through SharePoint or a web-like interface. And so this intranet interface enables every individual within the organization who needs access to this data to be able to actually interact with the Power Pivot BI capabilities. slicing, dicing, sorting, and filtering that information just by clicking buttons on the UI and discovering insights from that powerful analytical data. So that solution was the integration of Windows SQL Server, SharePoint, Power Pivot, and a myriad of core components that are required to drive that solution and integrate that solution. So this entire appliance solution was an exciting effort for us in that after integrating these solutions into the hardware and then building them out in the factory, we can actually deliver this solution to customers. And I've actually done this personally, so I know it's possible. I've brought in the appliance in a box into the customer's data center. We've unpacked it, racked it, cabled it, powered it up, gone through the configuration wizard, got it all completely up and running so that the administrators were ready to send out invitations to their workbook designers to begin creating BI experiences for their end users in under 45 minutes. So this is a really a great example of how we can bring together information into a very tuned and balanced infrastructure and deliver it to customers, enabling an extraordinarily rapid time to value. So on the heels of that effort, we implemented the Enterprise Database Consolidation Appliance in a joint engineering effort between Microsoft and HP. This effort has actually been going on now for, in the early design phases for almost 2 years, but we've been focused around customer validation on our design and deep integration for about the last year. And in the end of last year, we actually launched this product. It's now orderable worldwide, and we have customers around the world who are currently in process of driving workshops, proof of concepts, or in the process of acquiring this appliance. It's turned out to be extraordinarily popular for us, and I think you'll see as we move through the presentation today exactly why customers are finding this very compelling. It's the first database private cloud appliance jointly engineered by the largest software company in the world and the largest technology company in the world, designed to deliver an elastic and virtualized private cloud infrastructure, enabling seamless growth both of the infrastructure itself as well as of the workloads running within that infrastructure. It enables the consolidation of hundreds to thousands of databases with absolutely no application changes. So the migration process takes an existing physical instance in its current structure and brings that entire instance intact into the appliance as a virtual image. Once it's in the appliance, then we have the ability to do much more unified management. We have the ability to deliver high availability through clustering and disaster recovery through well-known constructs such as mirroring. And we have also brought together a unified appliance support structure so that customers who acquire the appliance have a single number to call where a level 3 premier support engineer will answer their call. These engineers are intimately familiar with the entire appliance, the hardware and the software within the appliance, and have the ability to lead the customer through resolution because they understand the infrastructure, they understand the components, and they have a tight working relationships with their extended counterparts. Our support engineers are able to provide tremendous support for these appliance solutions. In addition, the appliances leverage all existing hardware and software solutions. So when the support engineer that a customer contacts with an appliance needs to go to depth with a specific product engineer, that product engineer is completely fluent with exactly the product that's running on the appliance. They may not be fluent with all the ways that the appliance is put together, but the concierge leading the call is. And so that combination of depth technical expertise around existing industry standard products with premier support engineers who are intimately familiar with the appliance design enables our customers to address issues much more rapidly and with greater agility than ever before. Feedback from some of our partners and customers is that this is a great solution. The appliance is pre-built, pre-assembled, pre-tested, and has the potential to help deploy in days versus weeks or months. From Brian at Pragmatic Works. We're doing some great work over at Verizon, and their feedback enabled them was that this appliance enabled them to respond more agilely to business changes. The feedback we got from customers as our design initiator for this effort was customers were asking for a consolidation solution that could be implemented quickly so that the benefits could be realized more quickly. And that doesn't just mean the time that it takes to power it on. That means the time that it took to that customer didn't have to go through an engineering process validating all the various hardware and software components that were required. They didn't have to go through the build out and engineering process to determine that that solution would actually be functional. They can actually roll that directly into production and bring it up. Once it's brought up, of course, that's very rapid as well. But again, there's no question about the performance and capability of the solution so that the customer can begin very confidently migrating instances into the appliance or provisioning new instances as required, and know that the management and operational capabilities and the performance and tuning and support is there for them. So reducing capital and operational expenses is the key for standardization and consolidation across the board. Customers were asking for a green solution that used less power and physical space, both for the environmental as well as the economical advantages of that. We know from recent statistics that the cost of a server now is higher to run power and to cool that server over the life of the server than to acquire the server initially outright. So these operational expenses are a significant cost item, and reducing them by retiring old standalone servers and bringing those workloads into a much more efficient multi-tenant environment saves tremendous money on power and physical space and cooling. Customers wanted us to identify the right database servers to consolidate and to manage those solutions more effectively. So the identification of database servers I'll cover when we talk about the Microsoft Assessment and Planning tool. It was a joint engineering effort. We've been working with that team now for about 2 years to bake in the capabilities we heard customers needed. So we started that effort very early, and the benefits of that early effort are really coming out. The version 6.5 map tool is available now, and I'll talk about it later in the presentation. Customers needed to be confident and reduce risk, and the Appliance integrated hardware software solution designed jointly by Microsoft and HP really helps customers move forward and step forward with greater confidence. There is a solution reference architecture for this, which enables customers to get all the pieces and parts and to put it together on their own. However, we're seeing tremendous interest and momentum behind the appliance configuration as it's all been put together, racked, cabled, and the software preloaded and ready to be deployed by trained engineers, white glove delivery engineers. So the appliance offers significant advantage over just a standard set of hardware and software or the reference architecture in our view. It has the ability to consolidate, as I mentioned before, thousands of applications. And an important point to make here is that this is optimized for SQL Server. The slide is old. It's still talking about the code name for SQL Server 2012. But the SQL Server 2012 product actually had as one of its release criteria that it would run and run well in the appliance. And we've completed all of those tests and validations swimmingly well. So why choose the database appliance? I've talked about a couple of the reasons already. Faster deployment, and that isn't just the time, again, that it takes to bring it up, but to eliminate a lot of the engineering and design work up front and to eliminate a lot of the validation work after the unit is, after a bespoke solution is assembled, we can actually deploy this and deliver a confident platform right out of the box. It's a green solution, enabling customers to save tremendous money in power, cooling, and space. And we have some improved software on the appliance in terms of the integration software that brings the solution together and some of the tools on there that really help customers to address core scenarios. So customers always ask, what is the software that's included on the appliance? So to give a view of that, we have software at several levels. We, of course, have optimized the appliance for SQL Server workloads, but really the appliance is optimized for any demanding high I/O throughput workload, and I'll talk about how we size the containers, and that'll help to guide you on the workloads that run best in this infrastructure. We developed a lot of new tools and enhanced several new tools to be able to support our scenarios on the appliance, including validation tools, planning and sizing tools, health monitoring tools, and application management tools and capabilities. In addition, we used the Microsoft platform, the System Center portfolio, and the underlying SQL Server that runs that portfolio to act as the container management infrastructure within the appliance. This enables us to manage the virtual machines, apply appliance updates, provision new workloads, and also capture multi-tenant information required for chargeback. The infrastructure is running on Windows Server 2008 R2 with Hyper-V. It's the Data Center Edition, enabling unlimited virtualization. And we've also, through HP, added one-button firmware updates and storage management tools that actually can alert and identify any issues in advance of them becoming a production impact. So this is a little bit more detail about those tools and technologies. I mentioned earlier that we could grow seamlessly from a half-rack to a multi-rack environment, and this is a graphic describing that capability. Starting off with the half-rack, you can see that the blades infrastructure in the middle is half populated, and we have storage racks on the bottom half of the rack. As we grow from a half-rack to a full rack, we more than double the capacity of the appliance because the infrastructure is taking a slight amount in the first half-rack. So we linearly grow up to doubling our capacity within a full rack by adding additional blades and the additional storage units. We can then grow to a multi-rack solution, enabling customers to spread guests across multiple racks and expand their capacity and performance through that capability. We can reduce data center energy utilization and cost, and this is an illustration of an example of 200 physical database servers and racks moved to a single rack DBC appliance with the 200 instances running internally, and you can see an order of magnitude reduction in energy cooling and space requirements based on this scenario. And we're seeing customers who are typically in between this scenario and up to a few more months to get their return on investment on the appliance. So typically, as we're looking at ROIs, this is something that customers can actually acquire and through return on investment actually return their investment on this appliance in some cases as short as a year, and in many cases in just a bit above 1 year in the analysis that we've run with customers so far. This is really encouraging for customers to consider in the current economic status and really is compounded by some of the capabilities the appliance provides. So this cost savings is one fundamental enabler for customers to engage with the appliance, but some of the other capabilities are also very compelling. including support. So customers building out complex consolidation solutions have found themselves in a quandary at times. Some of our customers have found themselves after expending millions of dollars, find themselves in a mode where multiple vendors are involved in the solution. And when there's a problem with the solution, rather than all the vendors jumping in to help the customer resolve their problem, there's a lot of finger pointing and delay while the appropriate group to help with the repair is identified. In the appliance, we heard that pain from customers, and we built out integrated support solution that really improves the ability for customers to get back on their feet very quickly, resolve any kind of performance or production issues, and also enables our services partners to be able to create reusable services over this known infrastructure and to be able to deliver those services much more efficiently to enhance the appliance experience for customers. So both support and services are accelerated through the known platform we're delivering. Customers ask about the pricing of the appliance, and this is relevant. So what we've done is this particular scenario is looking at a full rack, not a half rack. So assuming that a customer wanted to start with a full rack of hardware, they could buy the hardware from HP. This includes the Windows Server Data Center licenses, and of course the price is approximately half for a half rack. These are of course retail prices. Many of you have negotiated very favorable discounts from both HP and Microsoft or our resellers, and so your discounts could apply towards the purchase. So these are retail. The management software within the appliance that actually runs the container infrastructure is priced out at a full rack at $128,000, and that's a combined price. It's $8,000 per processor. So customers acquiring a half rack or growing actually have a very linear pricing for the software as well. And again, these are retail prices through your Microsoft reseller. SQL EE licenses with software assurance enable customers who are deploying in a greenfield environment to acquire all the software licenses that are needed to run instances within the appliance and support unlimited virtualization. So this scenario particularly here is talking about a customer who's acquiring processor licenses for SQL Server Enterprise Edition with software assurance. And so this is a customer who's going in greenfield. Most of our customers who are working with the appliance will already have an existing licensing position and can take many of those existing licenses as is and move them into the appliance. So their current licensing position actually gives them a favorable pricing on the appliance. And as I mentioned before, there's several support options that are available via the concierge service in Mission Critical. And so adding support is really dependent upon rather than showing this step-by-step. So that they're visible for this graphic. These switches are designed to handle the container management traffic inside the appliance. These are not how the customer connects the appliance to their infrastructure. The way that the customer connects the appliance to their infrastructure is through the backplane of the blades enclosure, just as all the other server assets in the data center are connected to the networking infrastructure, so is the appliance. So the switches on top of the appliance, again, are there to handle and basically isolate the customer's network from the throughput required to manage hundreds to thousands of virtual instances within the appliance. And so this really isolates the customer's network from throughput required to manage and run this workload. The storage integrated into the appliance is leveraging iSCSI capabilities, which enable guest clustering as well as live migration using load balancing using live migration with no downtime. So the storage was turned out that the capabilities of the storage platform enabled some very powerful virtualization and consolidation scenarios. In addition, this is the most dense configuration that we could place into a single rack. And this density enables us to deliver phenomenal I/O throughput on the appliance. As you can see, the almost 400 spindles in a full rack is capable of delivering 60,000 I/Os per second. And this 60,000 I/Os per second is, for those of you who are engineers on the call and understand the I/Os per second, this number is a tremendous amount of throughput, which is required for demanding workloads like database instances. This I/O throughput is 8K packets with a 60/40 read-write mix. So these are real workload numbers that represent the kind of variable throughput that this appliance will deliver for customers when hundreds of applications are running simultaneously. And also the 60,000 IOPS is not a burst number, so we didn't just measure this for a fraction of a second and then use math to come up with the number of 60,000. We've actually measured 60,000 IOs per second over extended stress periods. So we know with confidence that these numbers are accurate. We've also rerun performance validation using multiple different tools, and we've actually published how to reproduce these findings for customers or partners who are interested in validating these figures. So this is something we're very comfortable and confident about. This infrastructure it's really elegant in that we've eliminated phenomenal amounts of connections and equipment and hardware to come up with the kind of balanced throughput that we're delivering. But one question we get from customers is, what workloads will run well in the appliance? We know for certain that SQL workloads run great in the appliance because we've tested them extensively. We also know that other demanding workloads work really well in the appliance as well. And so we built this container sizing guidance to enable customers to identify instances within their environments and then bring them into the appropriate size container on the appliance, enabling the customers and the end users within the organization to retain the performance capabilities they have in the server instances that are running on physical hardware today while they move into this virtual infrastructure and private cloud. So the large container that we built onto the appliance supports 4 virtual processors, 16 gig of RAM, 400 gig of formatted disk space, and 1,600 IOs per second for VM. But actually, if you take a look at this and say, well, what are some other container sizes that I may want to use, you can see that you can actually go up to 4 virtual processors, 64 gig of RAM, and 1.2 terabyte on a single disk inside of a single container on the appliance. So you may be asking, well, what if I have a very CPU-intensive application where I'm running, currently, let's say, 16 or 32 G7, current class processors, and I'm consuming every iota of CPU capability in that system. Is that going to run well in the appliance? The answer is no, very likely not. That's a very large solution, and you should continue running that on bare metal. That same answer would hold true if I said, if a customer came in and said, I've got, an analysis services box running with 256 gig of RAM, and I'm continually at the top end of my RAM capabilities on that analysis services box. Should I run that workload in the appliance? The answer again is no. Your workload, if it's consuming 256 gig of RAM in the current instance, it's going to be too large to run in the appliance. Continue to run that on bare metal. And then the third scenario I'll share with you would be a data warehousing scenario. where a customer comes in and says, hey, I've got a 30 to 50 terabyte data warehouse. Should I put that on the appliance? The answer again is no. That data warehouse solution should run in an infrastructure that enables full table scans of that data structure. That'll be the most efficient, cost-effective way of running that in the appliance, because you're running with hundreds of other applications. Even if you took the trouble to linearly lay down your data in your data warehouse, the access to that data would be randomized through all the other simultaneous users. So you want that running on an isolated system on its own bare metal. So the point that I'm making here is that the appliance, as capable as it is and as powerful as it is, runs about 80% of the workloads in the enterprises that we've looked at so far. But not every workload within the appliance is perfectly fit for the appliance. So we want to make sure that customers who have an environment are able to scan that environment and identify the instances. And one of the ways you can do that is leveraging the MAP tool, the Microsoft Assessment and Planning Toolkit. This actually enables customers to identify an inventory of the instances running in their environment very quickly. And then from that inventory, select the servers that they think may be interesting to assess as potential candidates for the appliance. So once those server instances have been inventoried and then identified, then MAP goes about gathering performance characteristics on each of those instances. By default, every 5 minutes, it's taking a performance snapshot of that physical server instance and then recording that information into a database. After several days, several weeks, or even up to a month, customers are then snapping that report and then performing analysis on there that we've built in with the support of the MAP team to be able to identify which of those server instances would fit well within the appliance, what size container is going to be appropriate to run that server workload in the appliance and give that level of performance the end users have come to expect, and can also tell the customer and the account teams how many racks may make sense for that customer to acquire to solve their entire consolidation challenge. And so this information has been extraordinarily helpful in enabling customers to determine which of my server instances are going to be good fits for the appliance, how many instances are going to be a good fit for the appliance, and how much of the appliance infrastructure would I need if I was going to consolidate 100% of the candidate workloads into the appliance. And so these are really important answers and are delivered through the MAP tool in a very concrete way. It's very predictable. We have leveraged very conservative placement guidelines in identifying these, so customers very likely could be a little more aggressive and still retain the performance capabilities. But we're trying to create a very safe environment for our customers, leveraging this guidance in the MAP tool to retain the performance and resiliency of the instances that are imported into the infrastructure. Again, the point that I want to leave you with is that while we're very carefully selecting only those server instances that will fit well into the appliance, what we're finding is that even though we're being very conservative on placing instances and identifying instances, still in the enterprises we've worked with so far, around 80 to 90% of their SQL instances will run well in the appliance. The other 10 to 20%, we encourage the customer to continue running on bare metal. And typically, those very large mission-critical systems are currently running on very new bare metal already. And so it's these other instances that really represent the opportunity for consolidation and virtualization. Migrating existing instances and provisioning new instances into the appliance represent two of our core scenarios. So migrating existing instances into the appliance enables customers to actually bring in servers using physical to virtual or P2V migration. This P2V migration is very flexible, but by default retains the IP and MAC addresses of the server instances as they're brought from physical into virtual. It brings the operating system It brings the database, all the data, every virtual machine. This is really important for customers to understand and internalize, because what that means is that if you had an existing, for example, backup infrastructure, and it was taking information from that server instance and then taking it to a shared SAN environment to do backups on a nightly basis, that backup will still work after the server is brought into the appliance, because that backup agent will still be running on the appliance, and the all of the IP and MAC addresses that the management software may have required to find that server instance are still intact and are still identical to what they were in the physical server instance. So this enables customers to retain the management capabilities that they've invested in over the last decades. For example, you don't have to make changes to your patch management infrastructure. Your guests will continue to be patched as they have been before. You don't need to make changes to your management and monitoring infrastructure. Those guests will be managed and monitored as they were before. You don't need to change your backup infrastructure. Those guests will be backed up as they were before, and so on. So these are important design constraints that we had as an engineering team that actually enabled us to deliver what we believe to be a very powerful solution for our customers, enabling them to retain the investments they've made around management in the data center. Provisioning newly created VMs is one of the big advantages many of our customers are seeing with the appliance. So let me give you a typical hardware-oriented perspective. A customer may come in and say, I need a new server instance, and it needs to have 4 cores and 16 gig of RAM and 400 gig storage space, and I need that instance as soon as possible. In a traditional acquisition mode, that could initiate a review process, which could result in an authorization to procure hardware and software licenses. Once those have been received by the customer, they can be unpacked and then assembled. Then the process of installing the various pieces of software can happen with each individual team typically coming in and doing their part in that process. And eventually the customer is notified that the server instance that they had requested is available for them to begin using. But as you can hear from that example, that could take some companies considerable amount of time. Your company may be more efficient in cutting that down, but typically the process is going to be longer than the couple minutes required to provision that instance on the appliance, where a customer can actually come to a self-service portal, request that the instance be provisioned on their behalf. This initiates a workflow process, which, if automated approvals are identified as appropriate, can push this approval straight through and enable the instance to be provisioned on behalf of the customer in mere minutes. If the administrator and operations teams are watching and actively monitoring the workflow process, then they can actually drive with that same speed in enabling customers or end users within the organization to provision new server instances literally within minutes. One clarification that customers have asked for is, what are you doing to separate the host and the guest environments? Let me explain what that means. The host environment is what actually runs the infrastructure, manages all of the simultaneously running applications within the appliance, reports health of all of those instances up to the data center. These are capabilities supported by the host. The guest environments are the workloads that are being requested by the business users within your organization. Those could be database instances that they're using to run line of business applications. And so these guest environments are run within the container management infrastructure and retain a lot of their current associations. The container management infrastructure, however, it's an advantage to the customer to isolate this infrastructure from the rest of the data center, because these workloads, especially when running simultaneously, produce a tremendous amount of demand on the system, and isolating them into an appliance enables the rest of the data center to operate efficiently and continue to deliver the great service levels you're providing without putting contentious and potentially offsetting workloads onto those shared infrastructure. Guest management, we're leveraging all of the capabilities that the IT team had in place to manage those guests, including monitoring, patching, backup management, and group policy, all continue to operate in the guests on the appliance. The host management capabilities that we built into the appliance leverage the entire System Center platform. Operations Manager for monitoring alerts and events, the Virtual Machine Manager for VM management, enabling physical to virtual migration. We use the self-service portal for provisioning and chargeback. We use Configuration Manager for patching the infrastructure within the appliance. Again, the customer will continue to leverage their existing patch management systems to patch the guests. And then we have Data Protection Manager for backup and restore for the appliance infrastructure, so that customers can, in the event of a disaster, have a backup that they can go back to restore their operations efficiently. Service Manager and Opalis are also included in the license. They're not actually baked onto the appliance, but customers who require advanced ticketing and workflow capabilities are pre-licensed to be able to enable those on the appliance. We also created on the appliance a host management node. This management node enables all of the consoles for all of these components I just talked about to be integrated into a single server. So from an administrative or operational standpoint, this really streamlines the operation of the appliance, giving you one server on which to manage all of the infrastructure from a single location. So the consoles from Operations Manager, Virtual Machine Manager, the Self-Service Portal, Configuration Manager, and Map, for example, are all integrated into the management node virtual machine. Again, streamlining the process of managing the appliance over time. I mentioned before that we baked high availability and disaster recovery into the appliance. Even if the physical instance you're running today wasn't highly available with clustering, you can make it highly available with clustering after it's brought into the appliance. So we've built high availability into the appliance really at every level. We've got redundant hardware at every level, redundant power supplies, redundant networking capabilities within the appliance, redundant storage hardware, so that if one piece of storage hardware fails, there's an immediate failover that the customer doesn't even notice. End users don't even notice that impact. And an alert is sent to the operations team to, for example, replace a drive. And there's time to do that because the rest of the system is up and running. Guests can be resilient through clustering. Again, I mentioned that we use the iSCSI drives on the appliance to enable that guest clustering. And we've also got database capabilities baked in that enable the instances running within the appliance to be able to be more efficiently managed and more resilient, including, from a disaster recovery standpoint, the ability to take instances on the appliance and leverage, for example, database mirroring to create a remote instance of that server, so that in the case of a data center emergency, for example, the entire data center loses its power for whatever reason, the secondary data center can still have those critical workloads functioning in that environment. And so disaster recovery can be supported on the appliance, leveraging very well-known and familiar capabilities such as mirroring, shipping of logs, replication of the instance, or backup and recovery. Our customers also told us they needed some advanced enterprise capabilities. For example, load balancing leveraging live migration. That enables customers to actually take instances from one blade and move them to another blade with no interruption in service whatsoever for the end users in the environment. So if you need to, if blade 1 is starting to get packed out, or instances on blade 1 need to grow because of requirements that are going to squeeze out other instances currently running on that blade, you can take that instance, move it to blade 2, 3, 4, or whichever blade is running in your rack, and move that instance over with no interruption in service to the end users in your organization. We also have the ability to have elasticity in our resource provisioning. So if a customer comes back and says, I need more CPU capacity, more memory, or more disk space, you as an administrator have the ability to adjust those capabilities for that customer and give them the capacity they need to be successful. And we've also integrated chargeback into the appliance. So as multiple applications from potentially multiple business units within the organization are sharing this infrastructure, our administrators have told us they needed a mechanism to equitably distribute those costs between those internal users. And the self-service portal gives us that capability. Here's some examples of some of the usage reporting. And you can see here that different applications here are consuming different amounts of resource and therefore would receive different amounts of chargeback. Chargeback is actually calculated on the appliance daily around midnight. So any new instance that was added, say earlier today, would then be tracked in chargeback as of midnight tonight. And the chargeback accrues daily so that if an instance is deprovisioned from the appliance, then again, that customer, the billing for that instance would terminate at the midnight the following night. So chargeback capabilities, really straightforward, easy to customize from the customer's perspective. You can identify different chargeback amounts or rates by the different resources that are identified in chargeback. And stuff that's identified in chargeback includes things like CPU, memory, storage, how much you've allocated and how much you've consumed. So chargeback gives a lot of capabilities for customers to be able to implement really robust chargeback that does equitably distribute costs between internal users. I want to summarize now to leave some time for answering any questions that you might have with this, and basically summarize by saying appliances deliver faster time to value. They enable customers to deploy and expand their capacities quickly and easily. Appliances reduce, this particular appliance dramatically reduces space and cost, enabling green IT, integrates unique management software, reduces implementation risks, and enables customers to seamlessly grow and scale according to your business requirements. As I mentioned before, the appliance is optimized for SQL workloads, but really is optimized for any demanding high I/O throughput workload. And we've tested extensively with multiple workloads and are seeing great performance. Our customers are actually going to be pushing the limits of this, we believe, much further than even we have, and we're excited to see the workloads and the success that they have as they're leveraging this infrastructure. Let's pause for just a moment and see if there's any questions from the participants on the call today. I'm happy to answer any questions that you may have or any comments that you may have. So let's pause for just a moment, Rachel.
Okay, hi. Yeah, we do have several questions. The first one is, Denali does not offer a data center edition. Also, Microsoft is changing the pricing structure to core-based. How does that impact your cost estimates?
So the cost estimates are, our current cost estimates are based upon our current licensing strategy, and so a lot of customers are acquiring the appliance to get into that, to the current licensing. As we go to the per core model, we are going to be reviewing our licensing for the appliance, and we'll be taking input from customers in that process. We're already getting some of that input. What we're finding right now is that the account teams and customers are moving forward with the appliance to address the licensing questions that they have, but we're confident that as the licensing evolves that we'll come up with answers that will enable customers to embrace this technology just as fully in the future as they can today.
Okay, great. Another question we have is, we are installing a 3-PAR SANS infrastructure. How does this integrate?
That's a great question, and we get that question from customers in almost every briefing. So many customers now are investing in shared SAN environments, and we believe that that's a really good business investment for our customers. However, these virtualized workloads that we're bringing into the appliance are extraordinarily demanding, typically far beyond the typical workloads that would be running or really optimized for a shared SAN environment. So many of our customers have taken these virtualized instances, very high I/O throughput instances, and placed them onto their SAN, and a few can work fairly well without dramatically impacting the other shared users on that infrastructure, that shared SAN. But as you put tens, hundreds of virtualized instances and really move forward with your consolidation efforts, many of our customers have found that this impacts adversely that shared SAN environment and penalizes all the other users on that environment because their performance goes down when these demanding workloads go onto the shared SAN. And so our customers have been very keen to isolate these workloads from that shared SAN investment. And this is one great way to do that. We still leverage your SAN. We have network outputs that are specifically dedicated on the appliance to connect to your SAN, to be able to stream backups, to be able to bring in data as required into the appliance. And so we definitely have dedicated ports and infrastructure for your shared SAN environment. But we recommend, and many of our customers are telling us that this particular workload is not appropriate for that shared SAN environment. We'd encourage you to take a look at that and determine how these workloads will impact shared users. We believe that once you have that, that we'll be having a conversation about the appliance, especially if you have a lot of virtualized instances that you're looking to consolidate.
Okay, great. And we have one more question. Does MAP work for the Oracle database as well?
Oh, that's a great question, and I believe it does. I believe it inventories the server instances in your environment. I'd have to double check on that, but I believe it does. And in addition, it looks at many other workloads other than SQL as well. And so we have the ability to identify instances in your environment and then size them into the appliance, whether they're running SQL or not. So that's kind of an exciting capability of MAP 6.5. And now that I'm thinking about it in memory, it does actually look at your other database platforms, including Oracle, and will identify those as potential candidates for bringing into the appliance. So yeah, I believe the answer to that is affirmative.
Okay, perfect. Well, that is all the questions we have right now, Mark. So I'm not sure if you have more to present or if we're done.
This is great. I appreciate the opportunity to connect with the teams. I guess I'd like to leave you with a call to action in that we're working very hard right now with our partners and our extended partner ecosystem, as well as HP, to deliver these solutions to customers and get them up and running on this infrastructure. So I'm on the product engineering team in SQL Server Product Group in Redmond, and my manager is particularly focused on not just throwing this product over the fence, but he really wants to see us take this product to our customers and help really put our engineering shoulder into these initial customer deployments. So it's actually my role for this year to focus with our customers on being successful on this platform. And I have a lot of colleagues who are shoulder to shoulder with me on that effort. And that's really exciting. I mean, this is a unique case where we've got, the hardware, software vendors who are going out of their way to bring core engineering teams to bear on customer success. So we're very keen to work with you. It's a unique opportunity for those people who are stepping forward with us as we're building experience around this capability. And this is a really exciting wave. I mean, I think everybody on the call sees the tsunami on the horizon of cloud. And this is really a great stepping stone to help companies understand the core capabilities of private cloud while retaining control of that data and preparing for the next wave of cloud infrastructure. So we're very excited to work with you. If you have interest in this solution, please don't hesitate to contact your account teams and your partner reps and have them bring us in to help you with briefings, with assessments, with site preparation, and ultimately with deployments and post-deployment work to help you come up to speed and be successful on this private cloud appliance. So my call to action to you is, if this is an area of interest to you, please let your account teams know immediately and schedule briefings and next steps so that we can work with you to be successful on this infrastructure. With that, I'll go ahead and close today. We leave with 5 minutes back in our calendars, and I'll look forward to hearing from those of you who are on the call with us today so that we can move forward with next steps. Thanks again, and look forward to hearing from you.
All right. Thank you so much, Mark. Okay. Bye.